We'll now go ahead and think about lyases and other enzymes, okay? So that finishes up what we should have finished on Thursday, half an hour late, no big deal. Today we'll move on to thinking about lyases, okay? So just like with the other classes of enzymes we talked about so far, I kind of showed you how they're subcategorized, right? So everything that's a lyase always is class 4, and the subcategory tells you what type of bond gets broken, right? Remember, lyases are enzymes that catalyze the cleavage of bonds without using water, okay? So for 1 are CC bonds, for 2 are CO bonds, etc. I won't go through all of them, okay? But what you can see here is that there are examples of lyases that break basically any type of, especially bonds focused on carbon. And also here for 6 are PO bonds. Okay, and then 4.99, and the .99 subcategory is always just everything else. Okay, so many lyases, many of them, do not require cofactors. Okay, so this kind of makes them unique amongst the enzymes we talked about so far. These don't always require cofactors. Okay, so if we look at aldolase, which is one of the central enzymes in glycolysis, it's responsible for splitting a 6-carbon chain into 2 equivalents of a 3-carbon chain. Okay, aldolase breaks a CC bond, so it would be that class 4.1. Okay, what we see here is we start off with a 6-carbon sugar, a phosphorylated sugar. Okay, the enzyme aldolase breaks the bond between carbon 3 and carbon 4, and we end up with an aldehyde, and we end up with this sp3 hybridized carbon on C3. Okay. As you kind of work through this mechanism, there is one complication that arises in that we generate a really high energy intermediate. So take a few minutes here and work through the first question on your activity. The strategy for this mechanism is reasonably straightforward, and the activity walks you through it. Okay. What you'll see about why that intermediate is high energy and why that's a problem.